perfect squares yesterday. Today we're going to talk about radicals. So what is a radical? A radical is like a fancy math word for basically what the symbol for a square root is. So this thing right here, we're going to do some vocab. The symbol itself is called the radical. The number in the front that's being multiplied out in the front, so this is multiplication. I'm going to put a little dot in there so you know it's multiplication. This is called the coefficient. We've seen that word many times before. Again, that just means a number multiplied to the front. And then we have a fancy word for the number on the inside of our radical. It's called a radicand. Everybody good with that? So, we simplify radicals in order to keep answers as neat and accurate as possible. That means in this unit, we will not be talking about decimals at all because square roots, simplifying these radicals, will help us avoid those decimals altogether. In order to do this, we are going to rewrite the radicand, which again is that thing on the inside, not radicand, radicand. It's the thing on the inside of our radical, radicand, as a product of its perfect square factors. Those are the things we talked about yesterday. We did that with some numbers yesterday where we just looked at numbers and rewrote them as the product of their perfect square factors. Here is a list of some perfect squares. Let's go down this list. Ooh, perfect squares. Let's go down this list. Starting with 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared 25. Can we keep going? 36, 49, 64, 81, 100, 121, 144, 169, 196. That's as high as we went yesterday. Here's 2 more for you. 225 and 256. Nice. 256 is our last one. Remember that one of our strategies when we do these problems that we're going to see in a second is that we rewrite all of these perfect squares in a list from least to greatest so that when we're trying to figure out what's the largest perfect square we can take out, we're going to work from the bottom up and divide out the largest one that makes sense and then go from there, go towards the smaller numbers. So again, this is a fancy property name. It's called the multiplication property of square roots. And it just says that if I have something inside of a square root, I can split that up into 2 things being multiplied together. I'm going to show you what that looks like. Determine the greatest perfect square factor. If I can spell, which apparently I cannot today. So we're going to determine the greatest perfect square that the radicand, the thing on the inside, is divisible by. So imagine like what we were doing yesterday, the exact same thing, except now we're going to put a radical around the whole thing. So let's take a look at number 1. What is the largest, the greatest perfect square factor that we can take out of 48? Look at your numbers. The largest. That comes out evenly. 16. 16 is the largest. So obviously I can't go 49. 49 is too big. So I'm going to start at 36. That does not divide out evenly. 25 does not divide out evenly. 16 is the first one that divides out evenly. So that's 16 times what? 3. So I'm going to write that as 16 times 3. I'm going to put the radical around it. Okay, remember yesterday we were underlining the ones that were the perfect square. So let's underline 16. What is the square root of 16? 4. So I know this is 4 times 4, so I'm going to write this as a little middle step for right now, just until we get the hang of it. And now whatever the square root of that number is, of my perfect square, I'm going to take it and it's going to move to the outside of my radical. So that 16 becomes 4, and it's now on the outside, and what's left on the inside is a radical 3, and that is my simplified answer. Does everybody see what I just did? I took this, I square rooted it, I put it on the outside. Let's do it again with 75. What's the largest perfect square factor we can take out of 75? 25 times what? 25 is the perfect square. 25 is what times what? So I'm going to take out a 5 and put it on the outside, and a radical 3, if I can choose the right color, is left on the inside. Good? What about 12? What's the largest perfect square factor we can take out of 12? 4 times what? So 4 is going to become on the outside 2. And then we have a radical 3 left on the inside. Good? Okay, what happens in something like number 4? What's the largest perfect square we can take out of 16? 16 is the largest perfect square. So what do we call this number? What do we call number 16? It is a perfect square. So what happens when I have a perfect square? I don't do all this nonsense. If I already have a perfect square, I'm going to square root that perfect square. What's the square root of 16? 4. I don't have to do all the nonsense where I'm simplifying and splitting things apart. I'm just going to write it as 4. So if I take a look at number 5, the square root of 36, my answer is? Great. I'm going to change something up really quickly. Look at number 6. I want us to put a number in the front. Ooh. I want us to put a number in the front here. What if I put the number 2 in the front here? The square root of 64 is, and then what happens with that 2? This is now 2 times 8, so my answer would be 16. So I changed that problem up a little bit. I put a 2 in the front there, but there will be problems like that. Any numbers in the front of your radical are just multiplication. So if the square root of 64 becomes 8, this is now 2 times 8 to get 16. Does that make sense? I'm going to show you 2 more on the next page. I'm going to save these 4 for you, so you will have to do those 4 for homework. Let's look at the next page. I got 2 more I want to show you that are a little bit special. Just a little bit. So one of our rules that we're going to continue talking about for the rest of this unit, but we're going to start talking about today, is that we cannot leave perfect squares inside of the radical. That means the number itself can't be a perfect square, and there can be no perfect squares that are able to be taken out of a number. So we're going to write the rule on the top. A little rule up here. No perfect squares left in radicals. Now, before I do these problems, what I recommend you do is I'm going to list all of my perfect squares from 1 to 256. So let's do that really quickly. I'm just going to rapid fire through these. Hopefully I don't miss one, because sometimes I do miss one. I got 2 more. Okay. Everybody listed them all out? It helps so I don't have to flip back and forth. I'm going to look at number 13 first. 13, big number, 441. That means I could try all of these in there. So I'm going to, you probably want your calculator for this. We're going to take 441. I'm going to divide it by 256, 225, 196, until I get one that comes out evenly. Somebody find me the first one that comes out evenly for that number. Did we find one? 49 times what? Okay, So let's write 49 times 9 inside of our square root. We know 49 is a perfect square, right? We're going to take that out. What does it become on the outside? So I have 7 radical 9. What do I notice about the inside? 9 is also a perfect square, so I should be checking my final answer. I see 9 is a perfect square, so what does the square root of 9 become? So now I have 7 times 3. My final answer then is 21. Everybody sees how that's happening here? Yes? Okay. We're going to do one more just like that. Try number 14. The number is 648. We're going to start with 256. We're going to work our way backwards. Let's find the biggest perfect square we can. Did we find one? I need a perfect square factor. I don't think it is 64. I don't think it is 64. 81 will come out of that evenly. 81 times what? Okay, so again, 81 is my perfect square. So on the outside, I should have a... What do we notice about 8? Is 8 a perfect square? No. So maybe this doesn't stand out to us right away because 8 itself is not a perfect square. However, can I take a perfect square out of 8? What perfect square can I take out of 8? So 8 now becomes the square root of 4 times 2. I still have this 9 out here. 4 is the perfect square, so I'm going to take out a 2. So now I have 9 times 2, and that square root of 2 is still left on the inside. Maybe I'll keep this green for our sake. So our final answer, I have the 9 from the first step, the 2 from the second step. That becomes 18 radical 2. That's a lot of steps. Did we all follow that? Any questions or things that I need to clarify for you? We're good?